Good day, students. This is your teacher, Daddy Cause, and in lesson 1 of this topic, we talked about organic acids and where they are found, their sources. So this lesson 2, we'll be talking about inorganic acid, or if you like, mineral acids, the ones you don't find from natural source majorly, but you prepare them in the lab. You call them mineral acids. So before we go to mineral acid, let's revise our lesson 1. We said that organic acids have natural sources. You find them from plant and animal. Like citric acid, you find them in citrus fruits, lime, lemon, orange. Lactic acid, you find them in sour milk. Uric acid is in urine. Formic acid is present in stings of bees and ants. Rancid butter contains butyric acid. Grapes contain tartaric acid. Apple contain malic acid. Fat contains stearic acid, fatty acid. Gastric juice contains hydrochloric acid. That's the mineral acid that you find in natural source. Hydrochloric acid present in gastric juice. Biology students will be taught gastric juice rather, the one that you produce from human stomach that aids in digestion. It contains hydrochloric acid. Then vinegar has acetic acid. Tea contains tannic acid. Tomato contains oxalic acid. Then food preservative contains benzoic acid. So that's that about lesson 1 revision. So let's move to mineral acid. What are mineral acid? Mineral acids are acid produced from from mineral element in the laboratory from mineral elements. You call them mineral acids. We have examples of mineral acids, and we have various types of mineral acid. Hydrochloric acid, like the one we have here now. We have hydrochloric acid. We have nitric acid. You call this nitric acid or triazonitrate 5 acid. We have other examples of mineral acids. The king of them, sulfuric acid, which is tetraoxosulfate 6 acid. Mineral acid is not only limited to all those ones. We have halogen acids of hydrogen and halogen, like hydrofluoric acid, hydrogen and fluorine. Hydrochloric acid of hydrogen and chlorine. Talk about hydroiodic acid of hydrogen and iodine. Then talk about hydrobromic acid of hydrogen and bromine. You call them halogen acids because they are formed from halogen: fluorine, chlorine, bromine, iodine. So we have other examples of mineral acid, like you can see on your screen. Tetrasulfate 6 acid, H2SO4. You can see that. Mineral acid. Talk about triazonitrate 5 acid, HNO3, also mineral acid. Talk about tetraoxophosphate 5 acid. Some people call it, old name is phosphoric acid. The new name is tetraoxophosphate 5 acid. Is a mineral acid. Tetraoxochlorate 7 acid, HClO4, it's a mineral acid. Trioxoborate 3 acid, it's also mineral acid. We have several examples of mineral acid, and if you can take note of these things, you are going to observe you are going to observe one thing common to all these acids. If you observe very well, you that they contain hydrogen. See hydrogen. In boric acid, see hydrogen. In tetraoxochlorate 7 acid, see hydrogen. So there's always hydrogen in acid most of the times. Look at the one that we have before, the halogen acids, you see that all of them contain at least one hydrogen atom in them. You see HF now contains acid. See, HF contains acid. You can see that it contains hydrogen rather. HCl contains hydrogen also. HI contains hydrogen. HBr contains hydrogen. So it's almost as if all acids will contain at least one hydrogen in their chemical formula. So that is what led to the definition of acid that we want to talk about. Actually, you call it Arrhenius definition of an acid, and is defined as a substance which will produce hydrogen ion. Like I told you that it has hydrogen in its formula, or you call it hydroxonium ion. They are the same thing, as the only positive ion when dissolved in water. Hydrogen ion or hydroxonium ion. Hydroxonium ion is an hydrated form of hydrogen ion. So that is how Arrhenius defined an acid. You can see HCl breaking down into H plus and Cl minus. Any compound that will produce hydrogen ion as the only positive ion when dissolved in water, you call that substance an acid. Look at that. When HCl dissolve in water, it gives you H plus and Cl minus. So that is how Arrhenius defined his own acid. Arrhenius definition of an acid. Now we have two types of acid based on their strength. And by strength in chemistry, we are not talking about how you can fight, how you can be like Andrew Joshua, or that's not what we mean in chemistry by strong and weak. A strong acid is an acid that will dissociate completely when dissolved in water. You know, acid that when you put them inside water, they form ions completely. They don't continue to stick together like a baby. A small child will not let the mother go. You don't say that the mother will not go to work because the baby is not strong, because the baby is weak. So the baby is always attached to the mother if that baby is weak. But a baby that will tell mommy bye bye when mommy is going to work, I will not bother following mommy, that baby is very strong. That's the concept of strong and weak in chemistry. A strong acid will ionize completely, or if you like, will dissociate completely when dissolved in water, while a weak acid will only dissociate partially. That acid is weak. It will not want to separate. It will not want to dissociate and form a separate ion. That kind of acid is very weak. But a strong acid is one which will ionize completely when it dissolves in water. Take a look at this diagram. We're having two demonstrations in this place. See, in this strong acid, use the hydrogen, the small balls completely separate from the big one. This acid is strong because the hydrogen and the other elements separated completely. But look at the weak ones. You will see the hydrogen still attached. Hydrogen still, even though they have already been dissolved inside water, and water is meant to separate them, but they could not separate. Only few are separating, like this one now have separated, but majority of the compound are still glued to hydrogen. See, this one is glued to hydrogen. This. So it is not completely dissociating in water. You call them weak. They are not strong, but they are weak. Only few of them are dissociating, like this dissociated, like this dissociated, but the rest, like this one, also dissociated. But if you count the others, there are very many molecules that are not dissociating. You call them weak acid. The one that dissociates partially, only partially in water. But the one that dissociates completely, like we have in this side of the screen, is strong acid. Strong acid. That's strong acid. So don't forget strong and weak acid. A strong acid is one that dissociates completely. Weak acid is one that dissociates only partially. Take an example of hydrochloric acid, a strong acid. You are going to observe that inside the solution, all the components separated. CH became H plus inside the water. Cl also separated H. You are going to see majorly ions. No molecule is clustering together there. They are all dissociated. They are all ionized. But if you come to weak acid, this acetic acid, or if you like ethanoic acid, for example, you observe that only these ones dissociated, the rest glued together. So acetic acid is a weak acid. See, in this one now, the hydrogen could not dissociate. In this one, the hydrogen could not leave because the acid is not strong. But if you look at this place, the acid is only this one is able to dissociate out of the many molecules inside acetic acid. So it partially ionizes in water, unlike here where there's a complete ionization. So in chemistry now you understand that when you talk about strong and weak, you are talking about degree of ionization. You are talking about extent of dissociation in water. So the one that will dissociate completely, these ones are strong, they are strong, they are strong. Why those ones that will dissociate partially, you say this one are weak? You know, it's very, very easy. Take an example of a boy that a girl jilted, and the girl say, I'm no longer doing again, just leave. And the boy will say, no, don't leave me, without you I cannot live, and all that. You are the sugar in my tea, you are the methane in my alkane, you are the cockroach in my cupboard, in fact I cannot live, and all those things. That boy is weak because the boy cannot dissociate from the girl. The boy cannot separate himself from the girl, so that boy is weak. But the boy that will say, okay, no problem, you can go your way, I have my life to live, you have your life to live, and that boy is very strong, you are strong at it. That is the concept of strength in chemistry. The one that will dissociate completely when it enter inside water is strong. The one that will still continue to hold on and will not dissociate completely in water, you said the acid is weak. So take a good have a good understanding of strong acid and weak acid right now. See another example here. You see that this is a strong acid. All the components are completely dissociated. No hydrogen is sticking. No hydrogen is sticking to any negative ion. Look at here also. Here is weak, an example of a weak base, where you still have some hydrogen sticking to negative ions. So this is a weak kind of base because there is not a complete ionization. Instead, there's a partial ionization. So here is a weak acid. Sorry, not base, weak acid. Here is a strong acid. Strong acid, where you have complete ionization. So that's another example also. So you know why this one is strong here. This is strong, there's complete ionization. This is weak, there's partial ionization of the acid. So take note of that. So we have complete ionization for strong acid, partial ionization for weak acid. Let's see examples of strong and weak acid. Strong acid, hydrochloric acid is a strong acid. Triazonitrate 5 acid, which we call nitric acid, is a strong acid. Sulfuric acid, tetraoxosulfate 6 acid, is a strong acid. Hydrobromic acid, all halogen acid apart from HF are strong acid. All halogen acid apart from hydrogen fluoride are strong acid. See hydroiodic acid, perchloric acid. Perchloric acid is tetraoxochlorate 7 acid. Chloric acid is triazochlorate 5 acid. They are all strong acids. Look at example of weak acid. All organic acids are weak acids. Take note of that. Oxalic acid is a weak acid. Benzoic acid is a weak acid because it's an organic acid. Formic acid, the one found in ants, is a weak acid. Or if you like, methanoic acid, they are the same thing. Acetic acid, all these are organic acids and they are all weak. Ethanoic acid is acetic acid is also weak. Now, sulfurous acid is triazosulfate 4 acid is weak. Phosphoric acid is tetraazophosphate 5 acid is also weak. Then nitrous acid is different from nitric acid. This is nitric acid. This is nitrous acid. Nitric acid is a strong acid, is triazonitrate 5 acid. Nitrous acid is a weak acid, is dioxonitrate 3 acid. So take note of that very well. Examples of strong and weak acids. See, strong acid, hydrochloric acid, nitric acid, we have mentioned hydroiodic, perchloric, chloric. Sulfurous acid is triazosulfate 4 acid, is a weak acid. Methanoic acid, you call that formic acid. Tetraazophosphate 5 acid is a weak acid. And hydrofluoric acid, that is the only weak acid among the halogen acids. Take note of that very, very well. The only weak acid among the halogen acid is hydrofluoric acid. Take note of that very well. So let's move on. Strong acids, I've listed them here. The one you've seen there, you can check for yourself. HCl, HNO3, H2SO4, they are strong acid. Tetraazochlorid 7 acid, strong acid. Triazochlorid 5 acid, strong acid. Hydrobromic acid, strong acid. Hydroiodic acid, strong acid. Then we also have weak acid. Ethanoic acid, weak acid. Hydrocyanic acid, weak acid. Tetraazophosphate 5 acid, H3PO4. Triazosulfate 4 acid, H2SO3. Methanoic acid, HCOH. Triazonitrate 3 acid, HNO2. Triazocarbonate 4 acid, H2CO3. So they are examples of weak acid that you should note. Weak acid that. So talk about H2CO3, triazocarbonate 4 acid. They are all weak acids. So you must be able to distinguish between strong acids and weak acid. You'll be needing it throughout your entire study of chemistry, and I want you to take particular attention to this lesson. Even if you are going to repeat the video again, master those weak acid and strong acid, be able to differentiate them, because you'll be needing them very, very effectively in chemistry. So let's see some questions. Answer this question by yourself. You can pause the video. Which of these is an organic acid? Then check the options, tell us which of them. A strong acid will be what? Check the options. What's the answer? You can pause this video to answer the question. Which of the following is a weak acid? So check it also. The organic acid are usually what? Are they usually strong acid? Are they weak acid? Are they highly corrosive? Are they bitter in taste? Check that also. Urine contains what? That is what type of acid is present in urine? Then number 5, which of the following mineral acid is present in human stomach? Then which of this halogen acid will not ionize completely in water? What's the IUPAC name of sulfuric acid? So look at the options, tell us which one do you think is phosphoric acid. What's the IUPAC name of phosphoric acid? Phosphoric acid, which of them is phosphoric acid? The strength of an acid depends on its what? Is it how it can oxidize? Is it how it can dehydrate? Is it how it can ionize? Or is it on how corrosive it is? Tell us what is the answer to that question. Which of the following pairs are weak acid? Choose which of these options that 2 of them are weak acid. Number 11, acid that sometimes have dissolved in water to produce hydrogen ion as the only positive ion. This definition is a definition of who? Is it a Bracellari theory? Is it Arrhenius definition? Is it Lewis definition? Is it Faraday's definition? Please, in that Brownstein-Lowry, it should be Brownstein-Lowry. The he is not in Lowry. So take note of that. So which of these definition is relating to the question that we have there? So let's see this essay part. You're also supposed to do this also. You classify these 7 acids as organic acid or mineral acid. That's essay 1. Then the last question here is you classify the following acid into strong acid and weak acid. So if you have any question, please you can put it down in the comment section below, and I'm going to attend to your question as appropriate. God bless you real good.